Hi, in this video we will go ahead and take our geometry and mesh it. So I'm just gonna open Salom to do that. And the reason why we take our geometry and mesh it is because we will be using a finite element modeling package, AlmerFem, which is able to do multiphysics, by the way. And finite element modeling works with meshed geometry, so we have to create the mesh first, and Salom is a very good package to do so. So let's go first into the geometry module. Alright, and let's import. As you can see, the preferred format for Salom is BREP, which is why we exported our metal bar as a BREP before. So we just navigate where our metal bar is and we just import it. Yep, that's it. So we can see our metal bar as we created it, with one face on the XY plane and the height along the Z axis. So the first thing we will be doing is to explode the geometry. So we select our metal bar and then we click on explode, and it will open up this dialog, and we can explode the entity into solid sub-entities. In this case there is going to just be one solid sub-entity, so apply and close, and we have our solid entity created from our parent original entity. So we will explode this solid entity some more, and we will be exploding it into faces. So let's go ahead and do it. So we have one solid and 6 faces, and you can see there are all the faces around our solid. So we are doing this because we want to model the elasticity of this metal bar so that we can model its vibration. And to do so we will use a finite element modeling, which will try to apply a governing partial differential equation to the 3D domain that constitutes our bar, so the solid. But these kind of equations can be solved only if boundary conditions are applied, and these are indeed the boundaries. So we made clear what the domain where we will apply the equation is, and we made clear what the boundaries where we will apply the boundary conditions are. So now that we did all of this, we can just go ahead and mesh this geometry. Alright, so this is the meshing module in Salom, and we just gonna make sure we selected our solid. We could rename all of this, by the way, but it is not necessary. So let's create a mesh. Okay, so let's go to the algorithm and select NetGen 1D, 2D, 3D, and let's define the 3D parameters. So this is actually one of the most important steps into solving a problem with the finite element method. The way we set up the meshing will dictate the accuracy and the convergence of the numerical method. I will discuss more of these as we go along with the series in the articles and in the next videos, but for the time being let's just keep things simple, and I'm just gonna set up a minimum size of 1 mm, a max size of 5 mm. I'm gonna make the mesh coarse, but I'm still gonna set it to second order, and they should give us some reasonable accuracy for the problem that we will be setting up with Elmer Fan. So I'm gonna click OK and apply and close. So this created a mesh, but we still need to compute it. Before we compute it, I would like to create groups from geometry, and we are going to select all of these entities, so all of our faces and our solid, apply and close. So now you can see that we define groups. So when we click with the right button and select compute, it will create the mesh for us. Actually, let's go ahead and do it. Alright, this created the mesh for us. There's a nice mesh information summary here, and what these groups are doing is that they are gonna take all the mesh nodes, or the points are the vertices of this tetrahedra, and since we use second order there are also points inside, and group them. So all the ones that are inside the bar will be into the solid group, and all the ones that end up being on the faces will be in the respective face. So I think we can save this project, and I'm gonna save it in our project directory. I'm gonna call it study, like this, so that if we need to maybe edit the mesh and change the parameters, we can open up our project later and do so. But in order for Elmer to use this mesh, we need to export it, so it is a similar thing to what we did with FreeCAD. When we export to a format that the next program we are going to use is able to work with. So this format will be UNV, and I'm just going to export the UNV as mesh. And that's it, and that concludes the video.